Let's take a look at a redox balancing example. This one will be in basic conditions, so we'll do the acidic first and then convert. So our first job will be to assign an oxidation number to each substance. We know that if there is a charge, then the sum of the oxidation numbers has to equal the charge of that ion. So O is -2, but there are 4 of them, so that's a -8. And so the chromium will need to be +6 for that to work out. The sulfite will also total -2. O is -2, 3 of them will be -6. So the sulfur in this case is +4. The chromium hydroxide has no net charge, so the totals are going to equal 0. We know that in this case the O is -2 and the H is +1. So if you do the math there, let's see, that's +3 and -6, so that's a -3. So the chromium has to be a +3. And then the sulfate's going to add up to a -2. -2 for the O's each, so that's -8 total, and therefore a +6 for the sulfur. So if you look at all of our oxidation numbers, we know that the sulfur goes from 4 to 6, so that's oxidized, and the chromium will go from 6 to 3, so that will be reduced. So there's our two half reactions, so let's write the oxidation half. And then also the reduction half. Now we're going to balance these separately. So we look and make sure that the S's are balanced, and they are. So now we balance the O's, and we said for acidic conditions that we are going to balance the O's with waters. I just need 1 so that each side has 4. That makes 2 H's. So I need to add 2H plus over here. And then we want to balance the charge. So this side right now has a total of -2. This side has a total of 0. So we're going to add electrons to the more positive side until both sides are equal. We'll do the same thing on the bottom. The chromiums are already balanced. There's 4 O's here, but only 3 O's here. So we will add 1 water. Now when you do the H's, there are 2 from the hydrogen, but there's also 3 more from this chromium hydroxide. So that's a total of 5 H's. And then when we look at the charge, we will need to count +5 and -2 for a +3, and then 0 and 0. So we're looking at adding 3 electrons over here. Now, when we go to add these back together, the electrons need to cancel, and they don't. So what we need to do is multiply by some factor so that we get a common multiple. So that's going to be 6. So we need to multiply this by 3. So that'll be 3, and 3, and 3, and 6, and 6. And then we need to multiply down here by 2. So that will be 6, and 10, and 2, and 2, and 2. Now we have 6 electrons and 6 electrons, so those will cancel when we combine these back together. Now there's some other things that cancel. I have 10 H's here, 10 H pluses that is, and 6 H plus over here. So if I think of it as combining like terms, I'm going to move all the H pluses to this side. That's like subtracting 6 H plus from each side. Well, that makes 0 over here and 4 left here. We also want to look for waters. There's 2 on this side, but 3 on this side. So these 2 will cancel with 2 of those, leaving 1 left. So let's combine this back together and see what we have. I've got a water, sulfite and 2 chromates. And then on the other side, I have 3 sulfates, 2 chromium hydroxides, and that's it. So this, wait a minute, I lost some H pluses somewhere. Okay, here we go, 4 H pluses left over. This is what it will look like in acidic conditions. Now, if I want to convert that to basic, I look at how many H plus I have, add that many OH minus to both sides. What that does here is it makes 4 waters. And then these 4 waters and this water will actually just make a total of 5 waters. And there is your new balanced equation in basic solution.